So with your investigation, we left off by looking at the closest distance between a line and a plane, yes? You should have got to the point where there was a formula that we just followed. Write that formula down in your notes. The book was making you go through and use it. Oh, we finish. There's the section, the exercise after that deals with the angle between two planes. Now, whether you use that in your investigation or not, we'll see. And we'll probably come and look at that in our double, but I just thought, let's be bold and do something that you haven't sort of done before, not just another quirky formula. Let's do something different, roll operations. And I think, look at that, you're going to love it. I'll change my name if you don't. Pressure. So, don't need to write this. But back in the day, when we had 2x plus 3y equals 7, and give us another one. I was thinking 4. Take 5y equals 12. And you had to solve this. So what did you do? Right, you make the coefficients the same. So we would have to times this. We would have to times that by 2. So the coefficient of x is the same. 4x plus, 6y equals 14. 4x, take 5y equals 12. You subtract. And so we're left with none, 11y, and so on. Now, what we skipped earlier on, right? Remember we said, oh, we'll come back to this. They were looking at if this was, these were 2 lines in thingy. If we put it as 2, 3, 7, and then 4 minus 5, 12. So we put this, it's called in an augmented matrix form. Seriously, I don't try that. Good. Oh, he hasn't got a pen. It's all right. Where would you have seen this before?
The word formula.
No? No? In your equation, your calculator. Equation. Simultaneous equations. You just put in the coefficients. So the deal is that what your calculator is doing is it's doing a little bit of work to go, well, I'll make that 2, I'll make that, keep that as 3, but I'm going to try and make this thing here 0. So if I have this as 0 and let's make, I don't know, that's 10 and then that's 20, I can go, huzzah, 10y equals 20. Well, we're going to do exactly the same thing, but instead of having an x and a y, we're also going to have a z. Now, if you don't have a system to go by, just trying to do this thing, you're going to be all over the shop. So it's a beautiful little process that we do. And just like induction, how you do it, you need to write it properly. Okay? So nice little heading, row ops, please. When we talked about just the lines here with simultaneous equations, what happened? We had the situation where we could have parallel lines, agreed? And what would that mean? No solution. Agreed? What was another option that we could have? So coincidence. So one is on top of the other. And what does that mean? Infinitely many. Infinitely. Infinitely many. And obviously the last one. Right, where they intersect and we have one unique solution. Now, how does this translate when we have an x, a y, and a z? We are not talking lines now, we are talking planes. So sorry, those at home, I've got visuals and you can't see it. So those playing at home, when we've got planes that we're talking about now with the x, y, z, these are all the different possibilities that we can have now. We are not going to be able to find solutions for every single one of these. We will be able to tell when they're coincident. Why? How could I look at the equation of 3 planes and know that they could be coincident? Multiples of each other, all have the same normal. So the A, the B, the C. we can find out when we've got intersecting at a line here. We will not be able to find out when they are intersecting at two different lines. We can find they meet at one point, not this, and possibly the common line, okay? So basically when they meet at one line, when they meet at one point, and when they don't meet at all. We can say that. All right, so that's -1 because there was a cross there, couldn't do it. Now, you can actually put these in any order you want. So these equations, obviously that 2 could have been first, but I would then make sure that my first row, if I had the option, if there was one in there where it had a 1x, I'd make sure that my first row was always a 1. It will just, you'll see what we're about to do, it'll make your life easier. Okay? So you don't have to stick in the same order, you can mix and match. All right, what are we trying to do? What we are going to try and do is end up, the first row is going to pretty much stay the same. We're going to try and make this into a 0, this into a 0, and then even this one into a 0. So that's what we're heading for. We will do this in our first step, second step, third step. And we will always use row 1. So here we go. 1, 3, -1, 15. How can you make this become a 0? Using row 1. We're going to go, that's right, we're going to say 2 times row 1. And how do we make them disappear? We can subtract row 2. Do we agree? This is the bit you're not going to like. You have to write this at the side. So maybe if you're doing a column on your page, fit it somewhere, the benefits are you are going to make a mistake. And it's going to be really easy to find a mistake if you can see what you did. So did you do something silly like 2 take 2 you said was 5? Or 1? It will happen. So over here, I will say, so 2 row 1, 2, 6, -2, 30. And we're going to subtract 2, 1, 1, 7. I don't know about you, but sometimes I forget to times every term by the 2. So I would have put 2, 6, -2, and then I might have put 15. So if I write it down. Yes, please. 2 take 2 is 0, 6 take 1 is 5, -2 take 1 is -3, 30 take 7 is 23. And we put that here, 0, 5, -3, 23. Are we happy with that? How am I going to make a 0 go here? One and 1, yep. So your choice, you want to go, yeah, I think row 1 take row 3. You can by all means say row 3 take row 1, but then you have minuses there. Doesn't matter, but I'm going to go row 1 take row 3, and because they are actually the same coefficients, I don't believe we have to do that to the side. So 1 take 1, 0, 3 take 1, 4 -1 take 2. We up with this? 15 take 0, 15. So this is pretty much now like your simultaneous equations. We want to now have a 0 here and a 0 here. How do we make that happen? You cannot use row 1 because if you do, this 1 will come into it and then we'll have something here again. So 1 is out. You're just using 2 and 3. So what am I going to do to make a 0 go here? Make these cancel. Bless you. You know it. You know it. Make them both equal to 20. So we're going to have 4 row 2 take 5 row 3. My teacher, when I did this, did the same stuff in year 12. He was really picky about, this is now a changed row, so you had to put a dash and then a dash, and I was like, oh, Mr. Pearson, come on. Love you, Mr. Pearson. we don't have to do that. Okay, so to the side, I'm going to go 0, 20 times in by 4. Take 12, 80, 92. Yes? Anybody with me? 25. What am I timesing by? 5, 75. Now, guess what? It's Monday, last lesson, and I'm going, oh, I wonder what 92 take 75 is. What do you think it's going to be without even thinking? I really hope it's 17. And yes, it is. So, therefore, this is minus 17z equals 17. So, therefore, z is minus 1. Can I now find y? Yep, we can now put it up into this one here, because this one is now saying that's 5y, take 3z. But what is our z? So minus 3 times 1, that's a plus 3, equals 23. Oh, how sweet is this? How sweet it is. And what do you think we're going to do to find x? Go back up here, solve. Now, Brody and the back row, can we just put it in our calculators? Absolutely, you can. Now, I was thrilled with the fact that people said, can't we do it on the calculator? Because that's what we should be doing all the time now. We have 270. That's right, $270 calculator now. Let's make it earn its keep. So yes, in we go, simultaneous. But how many unknowns have we got? 3. So absolutely, you can pop it in there, press solve, and it will do its thing. The problem is, this calculator won't give you... Thank you. Listen, please. This calculator will not give you the situation where we have infinitely many solutions. It won't give you the situation where we have all the planes meet at one common line. It won't do that. So we practice this with nice numbers to get our technique under control, and we can check using our calculator that we're right. You might even want to flick, I'll do it for you over here. What happened with the determinant? We could do that by hand, couldn't we? But we could also do it in the calculator. But why do we do it both ways? Polar form, why do we do it both ways? Because we can put an unknown in. So, right, we have suddenly got unknowns that are going to be in there. So we're going to take our time. We're going to make sure that this process is beautiful. And we can do it without making errors with numbers so that we can happily do it when there's unknowns in there. Oops, I wanted to pause. And it might be different to what they've done, but I don't care. We're our own person. I'm going to put this as my row 1. So it's going to be 1. This is just example B. Already popped. 1, 1, minus 1, 2. So how am I going to get a 0 here? 2 row 1, take row 2. So we're going to have 2, 2, minus 2, 4, 2, minus 1, 1, 5. 2 take 2 is 0. 2 take in a minute, yep. Minus 2 take 1 is minus 3. 4 take 5 is minus 1. So if you think I'm going quick, We're just adding and subtracting numbers, so let's hit it. It's going to say 3, row 1, take row 3. No one's asked, what happens if I don't put those little steps there? You'll lose them up, like induction, if you don't put using PK. Hence, or don't put the statement. This will be an overall, haven't followed the process well enough. I knew you did. If you don't do this thing on the side, that's not, I don't believe that is essential. However, if you make a mistake, this is so much easier to find if you have it there visible. Okay, so 3, 3 minus 3, 6. 3 minus 3, 3, 8. Subtract. 3 take 3, 6 minus 3 take 3 is minus 6, 6 take 8 is minus 2. Do we notice anything about row 2 and row 3?
They are scalars of each other. Which means they're on each other.
They're on each other. So we can do a couple of things, right? If I times row 2, so when I then do the next bit, which is 1, 1, minus 1, 2, 3, minus 1. So to get 0, 0 here, we would say 2 times row 2, take row 3. Agreed? But what we will notice is if I times this by 2, I will indeed get row 3. So it's 1 each is subtracting, and I'll end up with 0, 0, 0. The whole bottom row disappears. We know they're meeting at a common line. So could it be that it looks like they're meeting at a common line? Could it be that it looks like one of these? So could it be this one? Why couldn't it be this one? Because there's 2 that would have to be parallel to one another, so they'd have the same normal vector, the same A, B, C, or multiples of, and clearly that is not the case there. Okay, so we carry on, and this is what we have to do, right? We're going to say let Z equal T. Because this is all cancelled out, it means it could be anything. So we let Z be T. Therefore, how are we going to find Y? So we go back up here, it's going to be 3Y, take 3Z. But what is our Z? 3T equals minus 1. Therefore, Y will be minus 1 plus 3T all over 3. And then, how are you going to find Z? Put that back up in the top. X. I meant X. What did I say? Z. Crazy. Crazy woman. So we'll now go X plus T take Z. So, stuffed that up, didn't I? So we want to plus Y. So that will be plus, I'm going to write this as minus third plus T. Would you agree? I've divided each one by 3. Minus 1 over 3 is minus 1/3. 3T divided by 3 is 1T. Just makes my life easier. Pardon?
Go the next one, so into X.
Yep. Huzzah. So we get X plus Y, so that's going to be minus 1/3 plus T, and then we're going to take Z, which is T equals 2, so we end up with X equals 2 plus 1/3 to 2 and 1/3. Most of the time, X will normally have a T as well, but in our case, it's just like so. And that's what we would say, that's our equation that they meet in a line. or infinitely many solutions. T can be anything. Time for notes page. Okay. Before you write all of this madly, can we just actually listen? What am I doing? So what's the situation here? When we have 0, 0, 0, something, something. As long as this one B doesn't equal, or A doesn't equal 0, right? What happens then? I'll give you a clue. Unique solution. So as an example, if we had 0, 0, 10, 20, you could say, huzzah, 10 times Z equals 20, Z will equal something, you can go back and find Y and X, correct? Okay, e.g. What about this one? Will that be a unique or none? Not a trick question. Why don't you do, why is it unique? 0, 0, 5, 0. Is that possible? Yep, because 5Z equals 0, therefore Z equals 0, that is possible. So that is also a unique solution. What about the last one? Also unique? Pardon? It is no solution. Why? If you get to this, if you have 0, 0, 0 something, you go, oh my God, thank goodness. I don't now have to let T's be anything. I don't have to then go and find X, Y, Z. My job here is done. Because it's impossible for you to have 0 times Z equals 5, correct? Because 0 times anything is 0. So that's a woohoo! No more work.